Now we still want to talk about resultant vector, but for the case of two vectors acting at a point that are perpendicular. So the condition is with two vectors acting at a point, and the point in which they are acting at each other is 90 degrees. Like this example, it says find the resultant of the vectors as shown below. We have two vectors, 4 Newton and 3 Newton, two forces. Forces are examples of vectors, and they are acting at this point, and they are both perpendicular to each other. Now, how do you go ahead to sum these two vectors that are 90 degrees to each other to get their resultant vector? Like the rule applies for all vectors. When you are summing all vectors, irrespective of the number of vectors, you take the initial point of any of the vector. Pick one. Let's pick this 3n first. 3n. This is the final point. Then you take the other vector, you pick the initial point, you add it to the final point of 3n like this. So the initial point of 4n is added to the final point of 3n. Then you join it together. This one that joins it together represents the resultant vector. If you still wish to start with this first, like this, you just start with the initial point of 4 Newton, like this. Then this is the final point. Then you take the initial point of 3n and you add it to the final point of 4 Newton, like this. Then you join it together. This arrow is the resultant vector. You will still arrive at the same answer. Arrow and arrow here are still the same. Now, if you can look very well, you will see that these has formed a shape, and the shape of what these has formed is a right angle triangle. A right angle triangle, and this is good for us, so to help us find arrow. Since this is a right angle triangle, we can employ Pythagoras theorem to get arrow. We can employ Pythagoras theorem to get arrow, which would then be arrow square is equals to 4 square plus 3 square, because arrow is the hypotenuse side. Arrow is the hypotenuse side, while this is the other side, the other two sides. As you can recall, Pythagoras theorem said the square of the hypotenuse is equals to the sum of the square of the other two sides. The hypotenuse is r, so we square it. Then we now sum the square of the other two sides, which will give us this. Now, arrow square is equals to 16 square plus 9 square. When you add these together, you get 25. This will lead us to arrow square is equals to 25. Then you are looking for arrow, you square root both sides to get your arrow, which will lead us to arrow is equals to 5 Newton. So this is the resultant vector. Mind you, this is the size of the resultant vector, and as you know, resultant vector has both magnitude and direction. All vectors have magnitude and direction. This 5 Newton is just for the magnitude of the resultant vector. Now, how do you now go ahead to get your angle, your direction of your resultant vector? Because if you can find the angle, definitely what you have just found is the direction of the resultant vector. Now, how do you go ahead? But before I tell you that, mind you, once I have seen when this kind of question is given, something like this, so you will just join this at once, like this. 3 Newton, and for Newton. They just join it together and they solve for this arrow. Now, this is not totally right, but luckily for doing it this way, it will still arrive at the same answer. When two vectors are acting at the same point, you don't just join it to get your resultant vector. You must follow the rule that you take the initial point, add it to the final point of the other vector, then you join it together. Now, why is this working? Why is this case working where you just join the two vectors together at once? Why will it work this way? Why will it work? Now, recall, if you should take this now, you should take this just the way it was given. Now, you now decide to take the initial point of this vector and place it here to give you something of this nature. Now, you now take this vector, you now place it here. So it's still 3 Newton. Then you now take this vector, you place it here. Which is still 4 Newton. Now, what is this shape? This shape is a rectangle. It is a what? Rectangle. And in a rectangle and a square, the what? The both diagonals are equal. The diagonal here and the diagonal here is equal. Now, this is what I said you should avoid. You just leave 4 Newton and 3 Newton. So people just join it at once together, which is arrow, which is not extremely right, but it will give you the same answer. Now, this is what you are supposed to have done. Now, why is this not giving you the answer? Now, I'm telling you that it is because the diagonal of the two rectangles, this, which was this, and this, which is this, are both equal. That is why it is giving you the same answer. Now, in other quadrilateral, if you have a four-sided shape, the two diagonals may not be equal. So if you have a case like this, which we will discuss other time. Now, if you decide to join these together like this, now this diagonal here, let's call it arrow 1, and this diagonal here, let's call it arrow 2. Arrow 1 is not equal to arrow 2. So if you move ahead to join this vector together, which will give you arrow 2 is not the resultant vector. Arrow 1 is the resultant vector. So if you go ahead to solve for arrow 2 this way, you will be solving for a different diagonal, a different answer. Now, this, when you just join in this case, it gave you the same answer because in a rectangle, the two diagonals are equal. That is why you got the answer. Now, as we are saying, we want to find the direction of the vector so that we want to find the direction of the vector so that it will be a complete resultant vector, because all vectors have both magnitude and direction. What we just found here is the magnitude. Now, how do you go ahead to find the direction? Now, anytime you want to find direction of resultant vector, try to follow this rule. Where the resultant vector touches the ending of the vector that is on the horizontal plane or the horizontal vector, where the resultant vector is touching the resultant or horizontal vector, the horizontal vector, the one lying this way, look at where the resultant vector is touching the horizontal vector, anyone lying this way. Now, where they meet, locate that angle. You can call it theta. Now, that theta will not be the direction of arrow. Like this case now, arrow is the resultant vector. The other two vectors you started with was this and this. So where is this vector touching at? We say we are looking at resultant vector when it's touching at the horizontal vector, the vector lying down this way. So you're meeting this vector at this point. So you have to solve for theta here. So it is this theta that will now give you the direction of arrow. Please, that is always the rule we are going to be following. Where the resultant vector touches that vector that is lying down this way, the vector on the horizontal axis. Now, how do you go ahead to find theta? Now, this is a right angle triangle. Because you are looking for theta, you have two sides, but you are looking for theta, which is the angle. Now, it will now remind us of what we call trigonometry ratio. We have sine theta, cos theta, and tan theta. So which of the trigonometry is beneficial or right to find our theta? Now there is one mnemonic which some of you already know, which is called SOHCAHTOA. This is going to use sine, this is going to use cos, and this is going to use tan. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So let us look at what we are playing with so that we know which one to use. Now, because this is the angle, we have this side. Why make use of these two sides now? We have arrow already, so invariably we can make use of any of the three sides. We have arrow now, we have this vector, and we have this side, trigonometry. But let's just use these two sides. So with respect to this angle, this side is opposite. So we have opposites. And with respect to this angle, we have this side, which is what? Adjacent. So the trigonometry that carries opposite and adjacent is tan. Good. So we'll now say tan theta, which we are looking for, will now be opposite over adjacent. Opposite over adjacent. Now, tan theta, our opposite is 4 Newton, while adjacent side is 3 Newton. Now, to get your theta, you take arctan of both sides. Arctan to tan theta, arctan to 4 over 3. Because you have to divide 4 with 3 by 3 before you take the arctan, so you have to introduce a bracket. Now, this arctan will strike out this tan. You are left with theta. So our answer will now be arctan 4 over 3. Arctan 4 over 3. So if you divide 4 by 3 and you take the inverse of tan of that, you get theta is equals to 53.13 degree to 2 decimal place. 53.13 degrees to 2 decimal place. So this is theta. This will give you the direction of the resultant vector, and this gives you the magnitude of the resultant vector. Together, you now have a complete resultant vector, because it must have direction and direction. It must have magnitude and direction. Now we have another example with a story on it. It says a man starts from A and walks 3 kilometers eastward and then 4 kilometers southward. Find 2 questions attached to it. The total distance moved and its displacements from its starting point. So let's quickly give a pictorial illustration of the question. Now, he said, let this be point A, for example. He said, man start from A, this point A. Now, I walk 3 kilometers eastward. So, this way is eastward. So, he moves 3 kilometers eastward, not drawn to scale, but drawn logically. 3 kilometers. So, this is the initial point, this is the terminal point or the final point. And from this final point, that starts another journey again, continues another new journey. So then 4 kilometers southward. 4 kilometers southward, which is downward direction. So not still drawn to scale, but drawn logically. So this should be longer than this a bit. 4 kilometers. Now, this is two vectors. Displacement, because when the distance came, they came with their direction. So then I differentiate distance from displacement. Now the first question is, find the total distance moved. We are looking for what? Distance. Distance is a scalar quantity. The total distance this man has walked. Because it is the total distance the man has walked, you just to sum the first distance to all the second distance, which will now give us will give us total distance will be 3 kilometers plus 4 kilometers, which will give us 7 kilometers. That is the total distance the man walked. Because we are not looking at the direction. But the other question says, is displacement, find its displacement from its starting point. Displacement is not a scalar quantity. It is a vector quantity. So it includes both magnitude and direction. Now the man started here, moved with a displacement of this, moved with a displacement of this. So you are not asking is what displacement from his starting point. So the displacement from his starting point is always a straight line. It's always a what? Straight line joining the 2 points, which is the resultant vector. And you don't need to redraw it again, taking the terminal initial point of this and placing it in the final point, because if you follow the story, that is the way it is. The final point of this displacement, the initial point of this displacement was added to the final point of this displacement. The initial displacement of 4 kilometers, which is here, was added to the initial final point of 3 kilometers. So it follows the rule of adding two vectors. So the two vectors, which is these two displacement. Now we want to get the displacement, the sum of these two displacement. Now it will be the shortest distance between the 2 points, and you are joining it together, which is the resultant vector. So they say is displacement from its starting position. So you are looking at this distance and the direction, which will now give us this displacement. This line, which is the resultant of these two vectors, of which they were both displacement, they were vector. Now they were saying find the displacement of the starting point, which will now be this, which is also a vector, a resultant vector. So we need to find is what? Magnitude and direction. Now the direction will be from where this vector is touching the vector on the horizontal plane. So it is theta. Now find arrow. Mind you, anytime you are asked if somebody moves with direction, which is displacement, and he ends the journey, and you are asked to find the resultant vector, or is displacement. The displacement will not be the shortest distance from the initial point to the starting point, irrespective of how it moves. Whether it move from here to Abuja, Abuja to Lagos, and Lagos to Delta. So you now find the shortest distance from here to Delta State. The shortest distance from its initial point to its final point. That shortest distance is what will give you the displacement, because it is a vector quantity. It has magnitude and direction. From the last example, this is still similar to what we have arrow. So this is still similar to what we have done. The magnitude was 5, but this time around it is kilometer, and the angle was 53 degree. 53 degree. Now we have another question. It says two forces. It's a teaser question, extension question of what we are discussing on. It says two forces whose resultant is 100 Newton. Two forces. They summed it up and they've given the value for its the magnitude of the resultant vector to be 100 Newton. He said these two vectors are perpendicular to each other, showing the case we are dealing with. The two vectors are perpendicular to each other. He said if one of them makes an angle of 60 degrees with the resultant, calculate the magnitude of the vector. So let's quickly represent it with a diagram so that we'll be able to calculate the magnitude of the vector. Now imagine, just start with this vector. We don't know the two vectors, but they are forces. Now let's say this is F1, which will stand for the first vector or first force, and this F2. Now you, as the rule implies, you start with any of the vector. Let's say F2 now, you draw it out. This is the initial point and this is the terminal point. Then you take the initial point and place it of F2. You take the final initial point of F1 and place it at the terminal point of F2, like this. Then you join it together. This place is 90 degrees, because if you take it here at that same point, the initial point to the final point, they are 90 degrees to each other. Now where you join it together is the resultant vector. In the question, it is given to be 100 Newton. Arrow is equals to 100 Newton. Now can clear the arrow off. Arrow is 100 Newton, which is this. Now he gave one information which will help us find F1 and F2. It says if one of them make an angle of 60 degrees with the resultant. So it says if one of them makes an angle with the resultant 60 degrees. So this first force is making an angle here. This second force is making an angle here. So we are not told the force that is making an angle with this one, so with making 60 degrees. So you just choose anyone. Let's just choose this. Let's say this F2 is not making an angle 60 degrees with the resultant vector. Now our aim is to calculate the magnitude of the vectors. Now let's start with this shape is a right angle triangle, so we still use trigonometry ratio. So we want to first of all solve for F1. If you are solving for F1, because you are looking for F1, with respect to this angle F1 on this right angle triangle shape is the opposite side. So we have opposite. Opposite is considered, which is F1, and you will not go for F2 first. You will go for 100 Newton because it's a value to help you get your F1. 100 Newton with respect to this right angle triangle is the what? Hypotenuse side. So when you consider these two sides, the trigonometry that is right to use here is sine. So opposite over hypotenuse, sine theta. So it will not be sine theta is equals to opposite over hypotenuse. This will lead us to sine, our angle, our theta in this question is 60. Our opposite side is F1 and our hypotenuse side is 100 Newton. Now, to get your F1, you just simply multiply those sides, multiply both sides by 100. So it will now be 100 times sine 60 equals to F1 100 times 100. So you can multiply from the left and to the left, it doesn't matter. Now this 100 we cancel out. You are left with F1. Now you now be 100 times sine 60. Sine 60 will give us, sine 60 will give us, sine 60 will give us sine 60 will give us 0.86 F1. So F1 becomes 86 Newton approximately. F1 become 86 Newton approximately. Now you can still solve for F2. To solve for F2, you consider F2 with respect to this shape. F2 is now the adjacent side, F2. And you have the hypotenuse side, which is 100 Newton. Now, considering what the two sides we have, the trigonometry that is right to be used here is adjacent and hypotenuse. So we use cos. Cos theta is equal to adjacent over hypotenuse. Our cos theta, our theta will still remain 60 degree. Now adjacent side is F2 over hypotenuse side is 100. Another way of doing this, you can say cross multiply. So it will just, this will come and mean this is still over 1. So it will now be F2 times 1, which is F2. And 100 times cos 60. 100 times cos 60. Which will give us, first of all, F2 is equals to 100 cos 60. Cos 60 is 0.5, which will give us 50 Newton. So the two forces on this question was 50 Newton and 86 Newton approximately. Now we are done with two forces that are acting at a point that are perpendicular to each other. What about the case where you have still two forces but they are not perpendicular to each other. They are acting at a point at an angle that is different from 90 degrees. There are two vectors acting at a point, but the point they are acting at, they are not at 90 degrees. They can be any angle, 120, can be 45, can be 30. Now, how do you go ahead to sum these two vectors to get their resultant vector? That is what we want to discuss next.